everyone, welcome back. If you're out there building data platforms right now, you already know there is just an intense amount of noise out there. Everyone is talking about data lake table formats in 2026, and honestly, a lot of the commentary is completely missing the mark. So today, we're skipping the hype. We're looking exclusively at the architecture. In this explainer, we're going to break down exactly what's happening under the hood with Apache Iceberg and Delta Lake, and what it actually means for your day-to-day engineering workflows. Section 1. Not a format war. Let's just dive right in and debunk this industry noise immediately. You've probably heard this whole thing framed as some brutal winner-take-all battle for the data lakehouse. In fact, I saw this exact quote on dev.to a few weeks ago. It said, "The table format war is over, Iceberg won." I mean, it's a really clean headline, isn't it? Very dramatic, very definitive. Yeah, absolutely not. That massive strike-through pretty much says it all. That is not quite what's actually happening in 2026. The real world of data engineering doesn't operate on simple winner declaration clickbait. We really need to look deeper. Which brings us to Section 2, the metadata layer differences. Let's dive into this by looking at where these two technologies actually diverge. Because at their core, they sit on the exact same foundation. The entire debate, this whole so-called war, is strictly about the metadata layer sitting on top. Look at the bottom of these two stacks. Over on the left, in the icy blue, we've got Iceberg. On the right, in that warm tone, is Delta Lake. Under the hood, both of these formats are just storing your underlying data in Parquet files. Identical storage. Your bits and bytes on disk are exactly the same. The real question is how each format tracks what is actually true right now. So, how do they handle state? Well, Iceberg tracks state through a catalog coordination model. Delta Lake, on the other hand, tracks state through an append-only transaction log. It's literally just a folder full of JSON commit files and some periodic checkpoints. And this brilliantly illustrates the architectural split. Watch how this builds. On the left, in the icy blue, Iceberg uses this highly adaptive metadata tree. A metadata file points to a manifest list, which points to manifest files, which finally points to your actual data. It's very hierarchical. Now look at Delta's warm tone on the right. It's a completely linear transaction log path. You've got a Delta log directory tracking JSON commits sequentially. No external catalog required just to read the current state. You just point a Delta-aware engine at the storage path, and boom, you're done. So what's the crucial trade-off here from multi-engine concurrency? Iceberg is built to coordinate universally. Because it uses that catalog API, multiple engines like Trino, Flink, and Snowflake can all commit safely at the exact same time. It was designed for universal engine interoperability from day one. Delta, though, is deeply native to Spark and Databricks. Its write coordination is incredibly fast and incredibly mature within that specific ecosystem. But historically, it definitely required a bit more effort to write safely from outside engines. All right, Section 3, the 2026 convergence. This brings us to the actual 2026 story. Let's just officially drop the format war framing entirely because it's completely obsolete. The real story isn't one winner taking all. Notice how our icy blue and warm tone diagrams are literally sliding toward the center and visually merging here? That's what's happening. Convergence. Each format is physically absorbing the other's best ideas and architectural features. They aren't trying to destroy each other, guys. They are fundamentally becoming more like each other. For example, take Iceberg III, which hit public preview on Databricks back in April. Just look at what it lifted directly from Delta's playbook. Deletion vectors for highly efficient row deletes, row lineage for tracking provenance, and a native variant type for semi-structured JSON data. That old feature gap that used to separate these formats, it is rapidly closing from Iceberg's side. But hey, the borrowing goes both ways. Databricks is currently proposing that Delta 5.0 actually adopt Iceberg's adaptive metadata tree structure. That hierarchical manifest model we looked at a minute ago, Delta wants it. Both ecosystems have realized that both architectural paths discovered some essential truths about managing massive data at scale. Section 4. Seamless engine interoperability. This convergence leads us to the most practical part of this explainer, how this interoperability actually works for you in practice today. Because right now, you really don't need some massive, risky migration project to get these formats to play nicely together. The absolute magic word here is uniform. Delta Uniform is a feature where Databricks automatically generates Iceberg metadata right alongside your normal Delta log, and it happens entirely in the background. There is no manual pipeline you have to run or babysit. See how beautifully clean this is? You maintain exactly one set of Parquet files. One single source of truth. And yet, it's natively readable by Delta engines like Databricks on the left, and natively readable by Iceberg engines like Snowflake, BigQuery, Trino, and Drumeo on the right. You are achieving universal engine compatibility without copying a single file. It's brilliant. And for those of you working in the Microsoft ecosystem, this gets even better. Microsoft Fabric's OneLake now exposes an Iceberg REST catalog endpoint. Delta is still absolutely Fabric's native format. Every lakehouse and warehouse you build there writes Delta by default. But OneLake basically just virtualizes it for you. Let's break this down into 3 super simple steps to prove how seamless this bidirectional interoperability really is. Step 1. Your Fabric lakehouse writes native Delta. Step 2, your Iceberg native tools can query that exact same data via the REST endpoint without rewriting any files. And step 3, it works in reverse. You point Fabric at your Iceberg tables in S3 using shortcuts, and Fabric reads them as if they were natively Delta. No migration, no data duplication, just completely seamless access. Section 5, where lock-in actually lives. So think about it. If the file formats are converging and interoperability is basically a solved problem in 2026, where does that actually leave your architecture? It forces us to pivot to the real decision data engineers have to make right now. Here is your peer-to-peer cheat sheet. If you are deeply multi-cloud or your primary engines are Trino, Flink, Snowflake, or BigQuery, you should default to Iceberg and a REST catalog, period. If your organization is Databricks first, stay on Delta and simply flip on Uniform for interoperability. And if you're on Microsoft Fabric, you're on Delta natively, and OneLake's virtualization handles your Iceberg compatibility. Choose your format based entirely on your primary infrastructure. Because the real 2026 shift is this. The meaningful decision has moved up a layer. It's about which catalog and governance system your organization ultimately commits to. That is where the actual lock-in lives now. It is no longer in the file format sitting underneath it. Your governance layer dictates your security, your access control, and your enterprise architecture far more than whether your metadata happens to be written as a JSON log or a manifest tree. To help you navigate that exact governance decision, I've put together a complete written guide. It contains a full feature comparison table, the uniform requirements checklist, and a really exhaustive breakdown of the whole catalog ecosystem. Unity Catalog, AWS Glue, BigLake, Polaris Nessie, with every factor mathematically scored for your specific use case. The link is right down below. And if you want to know exactly how this architecture debate translates to getting hired, click the card on screen right now to see my breakdown of what a hiring manager actually tests for in a real data engineering interview. Ultimately, if the file format is no longer your biggest lock-in risk, you really have to ask yourself, are you auditing the right parts of your modern data stack? Thanks for hanging out, and I'll see you in the next one.